First, let me explain this. Audience, listen. Now, let me explain about what is the significance of incorporating this error compound. Sir, is it audible? Audible? Yeah. Okay. So let me explain the significance of introducing this U. This is very important. If there is no U and there is no econometrics. In fact, there is no statistics because everything is based on science. Understand? No? So y is equal to a plus bx. That means it's like a H2O. Correctness completely like a H2O. It's a scientific. It's a science, becomes science. So here, y random component? Because you know that I told you, y is not only explained by x, it is also explained by the other variable which we are not incorporated in the equation. Understand, no? Because we call it as parsimonious model. The parsimonious model. What is the parsimonious model means? You keep your model as simple as possible. For example, sir, I will go with FDI is a function of GDP. Okay, FDI is a function of GDP. Otherwise, let me give the other way, it's easy to understand. GDP depends on the FDI inflows. What is FDI? Foreign direct investment inflows. People, So the foreign direct inflows leads to increase in GDP, increase in economic activity. Correct? No? So GDP is a function of FDI. Simple example. Okay. So now you know that I want to keep this model as simple as possible. I am not interested to go for incorporating more variables. There are many reasons for it. Okay. So this is, you are keeping the model as simple as possible by ignoring the other factor. But what I'm doing instead, I'm going to incorporate U. Correct? No. So this become y is equal to a plus bx plus u. So U is GDP, X is FDI inflows, and U is the error term. What is the error term? The component, the factors which influences Y, but we have not incorporated in the equation. Understand, no? So those unobservable factors are part of U. You understand, no? Unobservable, we call it as unobservable effect or unobservable factors which we are not incorporated in the equation. Okay, so that is random. So that will know this U we are not incorporated. So this U will capture the impact of other factors on Y. So that is the reason we are introducing it. There are many reasons. This is one reason. Second, so what you supposed to do? You have to incorporate more. You have to incorporate more variable to minimize the effect arises from the error component. You have to minimize it. Second, this is one. Second, the using of poor proxy variable. You know what is proxy variable, right? See, for example, the GDP. Sometimes GDP is available, you know that GDP is available in quarterly. You understand, no? GDP is available in quarterly, not in monthly. Is there any proxy that is used for GDP? Some studies which I referred, they used IIP. What is IIP? Index, very good. Index of industrial production they used. For what? Proxy for GDP. It might be poor proxy. Understand? No. It might be poor proxy. So which will affect the relation. That also will taken into consideration. Poor proxy variable. Okay, I'm not advising you have to use the poor proxy variable, which will be controlled by you, but the effect arises from poor proxy also. And also, how hard you try, there is always some randomness in the behavior of human being. Okay. Otherwise, that will be captured under you. Otherwise, there's one more reason we'll say. The errors of measurement. What are the errors of measurement? Sometimes the household expenditure. You take consumption expenditure. Consumption expenditure or your income usually mentioned in terms of decimal points. Correct? Yes or no? The expenditure is always comes out with a decimal point, right? So what sometimes we'll do, we will round off. Sometimes we'll round off. So we call it the errors in measurement. Errors in measurement. Okay. So those errors will be captured by you. So the key reason is the y is influenced by x, but actually the y is influenced by the other factor called, let's say, y1, x1, the x2, x3, x4. The y1 is influenced by the other factors. So other factors are not taken into consideration, and this will be a part of u. That is the main reason. Apart from it, the randomness of human behavior and the errors in measurement of data, and using a poor proxy, and keeping the model as parsimonious as possible. Many reasons for it. So the main reason is optimal. So we are ignoring the other factor. So that will be a part of your U. That will be a part of your U. Okay. So you understand why we are using. So by adding U, it has become an econometric model. By adding U, it become a econometric model. Okay. So now what I'm going to do is, I'm going to which is very important here in this equation, we want to find out the impact. This is the independent variable. There are three components here. Okay, so y is explained by two components. You know that. Y is explained by, this is a plus bx. A plus bx is the deterministic component. Deterministic component. And u is the random component. The error component. Okay, two component. So which is important here? The deterministic is very important, and the effect arises from the error component should be minimized. The effect arises from the random error component should be minimized. That's the logic behind the estimate of OLS, minimizing the error criteria. So error minimizing criteria. Error minimizing criteria. I hope you know that TSS, total sum of square. You heard about the total sum of square. If you look at the study regression, you know that TSS is equal to total sum of square, which is equal to the regression sum of square or explained sum of square in some textbook. Explained sum of square plus the, let me keep this RSS. Explain sum of square, and this is RSS. Okay, so what is this RSS? Total sum of square is equal to explained sum of square plus the residual sum of square. So what do you mean by the RSS? What is this ESS? What is this TSS? TSS means the variation in Y is explained by X. Correct? No. The variation in Y is explained by variation in Y. Correct? No. The change in income, the explanation is change in consumption is explained by change in income. Change is nothing but the variation, the variance. So total sum of square is equal to explain sum of square by plus, there are two components. I want to give not error sum of square and regression sum of square. Let it be. There are different notation they are using. Regression sum of square is nothing but usually it is based on the explained sum of square, which is nothing but the explained factor, that is X. But there is U here. What is U? U is a part of error sum of square. Error sum of square. So here what we need to do, we need to minimize the error sum of square and increase by increasing the effect of TSS by increasing RSS. What is RSS? A plus B X. This is nothing but explain. This is nothing but your RSS. You want to keep explain sum of square or the residual sum of square also, fine. So what I want to say here, the variance, I'll write in a simple way. Variance in Y is explained by variance in anyone. Variance in X is explained by variance in Y is explained by variance in X plus unexplained variance. What is unexplained variance? What is unexplained variance? Anyone? Very good. The error. The variance from the error. That's what I mentioned here. Say explained sum of square plus this is also some textbook unexplained sum of square or maybe the residual sum of square. Okay, so here what I'm saying, listen carefully. The variation in Y is explained by variation in X plus unexplained variance. Unexplained variance is nothing but arises from the U. So which one is important here? The variance in Y is explained by variance in X. I don't want this. This has to be minimized. So how to minimize? Anyone? How to minimize? How to minimize? Any idea? How to minimize?
By using OLS.
Beautiful. By adding more variable. Beautiful, man. By adding more variable. When you are adding more variable, which will go up? The explained sum of square will go up, and this will, you are minimizing the error. By minimizing the error. So based on this only, we have the statistic, the component, R square, the value called R square value, which measures the goodness of fit. It is based on the explained sum of square and total sum of square. Okay, this I'll come to that while estimating. Okay, R square value. So what I'm saying, you hope you got some idea about U, right? U is taken into control of the other factor which does not included in the regression equation. So we want to focus on incorporating more variable. Don't just leave it. Okay, your error term will take care. No, so incorporate more variable to minimize the effect of the error unexplained variation. Okay, so what are the consequences? So that your model is best fit for the data. Your model will be best fit for the data. Sir, how to find out whether the model is best fit or not? So using R square. While estimation, I will come to that. Okay, so you got idea about U, right? Okay. So what I will do is, and one more thing I want to tell you, U is also a value. Don't just think, sir, this error, once you estimated, the error become a residual. The residual is a series. Residual is the series. Yeah, sir, what is the logic behind it? You see here, the residual, let me explain. There are function called PRF, probability regression function. You know the difference between population and sample, right? The sample represent the sample is a subset of population. The sample represent population. Correct? No, but there is always error, which we call a sampling error. Those who are dealing with the primary data, they say they always try to increase the sample size. Why? To minimize the sampling error. Here also same function. Here also same concept. PRF. Okay, PRF. What is PRF? Y is equal to A plus B X. There is SRF. the SRF represent population, which is nothing but the y hat, which is equal to a hat plus b, sorry, a plus b x hat. So I can rewrite this as y is equal to, since sample regression function represent PRF, so I can write y is equal to y hat plus, what is the one more component? What is the one more component? Plus you put E, no problem. So I want to bring the residual here. You understand? No? Okay, so how can rewrite? So y is u is equal to y minus y hat. So u is equal to the difference between actual y. Student listen. The u is the difference between actual y and estimated y. So what is u? What is u? The residual is equal to y minus y hat. Sir, actual y I know. What is actual y? Actual y is the data that you are given to the software. Then what is y hat? Y hat is calculated based on the model you are running. So students, this is actual minus. How this value? This value is based on estimated. So actual minus estimate is nothing but your residual. Okay, now I am going to show you this residual is also a component which is also follows the probability distribution. It is a series. It's a variable. If you want to keep a variable, yes, I will estimate and explain what is y hat. The difference between y and y hat is the residual. I'll show. But why I am explaining this? The residual has certain property. So the property, that means the properties of economic model is based on the residuals. So you should know the concept of the residual. Residual plays a major important role in econometric model. Okay, when I show this model, what is behind the screen, you can understand what I have explained clearly. Okay, let it be this. So I will estimate the model now. I will estimate the model. I'll write the interpretation and I'll show you the residual component and what are the properties are associated. Assumptions, in fact, assumptions are associated with the residual. Okay. Fine. Yes, ma'am. Madam, what is PR? Basically, you come. See, this is with respect to regression model. Regression model. So PRF, what is PRF? Population. This is represented by graphical also, graphical method. So what is PRF? Population regression function. You know regression function. Population means it is considered y is equal to a plus bx plus u. Let it be. Okay. Now what is SRF? A sample. But you know sample represent? But I am going to use sample means it is estimated. Why? Because you are using sample to estimate. So y hat is equal to a plus b x. So let me u, or you want to use e or no whatever. So plus e if you want also. Or u1, u2. Or you leave it, no problem. Now, come to the, I want to explain the PRF is equal to SRF. You know that because the sample represent population. So, y is equal to y hat, which is left out, plus the error component. You understand, madam? Now, I can bring this mu, the error of this side, the u is equal to y minus y hat. So this u is error, nothing but the u minus, sorry, y minus y hat. What is y? Y is the actual input. Y is actual input. Whether it's a GDP or FDI, it is the stock market price or inflation, exchange rate, whatever it is, your input. What is y hat? Using this data, the regression is going to estimate. It's going to estimate each value. each value, calculate each value of y. Okay, so y minus, what is the difference? Y minus y hat. What is y? The actual input. Actual input. What is y hat? Estimated value using this y. The difference, no. The difference is nothing but your unexplained, which is nothing but u. That I will show you. I'm going to explain through graph. Easily you can able to follow. Easily you can able to follow. Okay. So now I'm going to estimate one OLS model. OLS means what? The regression model. So then we'll see. Okay. We'll start now. I'm going to use EViews. So you please open. You have EViews. Hope so. You have EViews installed in the system. I'll open and estimate a model. From this model, we can learn, okay, to how to write an interpretation for a model for each and every coefficient. Okay, what is the diagnostic test that for a model? We will see one by one. Okay. Sir, is it working, sir? Sorry, sir. Okay. So before going to the practical, the hands-on with regression. Okay, so let me share a PPT. I'll share a PPT. I'll explain the assumptions of the residual component. Okay, so there are three assumptions. There are many assumptions of a model, econometric model. Okay, there are three assumptions. What are they? First one is, one by one I'll tell you. With respect to u, okay. Let's say the consumption and income. Take this example. Which is the target variable? C or Y? Which is our target variable? C or Y? Our target variable is, regression is C. Forget about Y. Y is independent variable, which is explaining C. Okay, let's say example. This is in terms of rupees. 12, 11, 10. Understand? No. It is a variable. Two variable. It's a variable. Okay, C. Consider this as Y. Y means normal. Y variable. This is 9, then 15, 18, 13. Now let me move on to the, now after estimation, this is actual C, which you are given as an input. This is an input. Okay, this is an input. So after using the regression model, you will get estimated C. That means what? Y hat. What is the value? Sometimes 11. See, each observation will be estimated. Try to understand what has happened behind the screen, the software. Each Y is represented by Y hat. It is not summation of Y. It is not, we look only the summation of Y. At the end, after estimation, 12 become, example, 11. 11 become 10. 10 become, let's say 10. No problem. This is input, actual data. This is estimated using, very good, estimated using regression, your econometric model. Now you see 10, then 9 become 8, 15 become 14, 18 become 15, 13 become 12. Now what we want actually, what we want. Residual. U hat. What is U hat? U hat is nothing but y minus y. So what is the difference? What is the difference? It can be minus or it can be plus. Residual can be minus or plus. Try to understand. Maybe, okay. Okay, here what is 1? Here again 1. This is 0. Here it is 1. Here it is, okay, 14. You put 14, no problem. Or you want to go with 16 also, go ahead, no issues. Or some part, okay. So here it is 1. Here it is 3. Here it is 1. Sometimes, listen, sometimes it will be minus. No need to worry. Here, for our understanding, all are positive. Now here, how many series we got? This is actual y. This is estimated y. And what is this? This is the residual. How it is residual? Because it is the difference between y minus y hat, or c minus c. So this is the residual. There are certain assumptions with respect to this component. There are certain assumptions with respect to this component u. So what are those assumptions? First assumption is the 3, not 2 assumptions with respect to, there are 5 to 6 assumptions. 2 important assumptions I'll give you. First one is three important. First one is related to the variables, independent and dependent variable. The next 2 assumption is with respect to the residual. The first one, please make a note. First one, no autocorrelation. First assumption is no autocorrelation. Very important. Second assumption is no multicollinearity. I want these 2. Because mostly the articles, they keep on proving that this model is not suffer from, yes, the multicollinearity or autocorrelation problem. Okay, so please, no multicollinearity. Last one is homoscedasticity. Equal variance of constant variance of the residual term, the error component. Okay, homoscedasticity. This we'll see in detail later. Homoscedasticity. This we'll discuss about now while studying the ARCH and the GARCH effect detail. These 2 very important, because normally the last issue is arise with high frequency data. What is high frequency data? Daily, intraday, tick by tick data. You will end up with the problem heteroscedasticity. Unequal variance of the residual component, the squared residual. Okay, so that we'll discuss under the ARCH and GARCH effect later. Now here, when you go with the OLS model, and these 2 are very important. What are the 2? One is no autocorrelation. The other one is no multicollinearity. Okay. What is no autocorrelation? When you are writing PR, okay, when you are specifying this equation, y is equal to a plus bx plus u. You know only this equation, right? You know only frequently you heard about these equations are y is equal to a plus u. But if you look at the actual form here in terms of PRF and SRF, this is segregate into each equation, each PRF and each SRF. Okay, let me explain that. This will be, let's say, n is equal to 20. What is n equal to 20? Number of observation is how much? 20.
20.
Or 30, or 20, whatever it is. So how it will be splitted? Y1 is equal to A1 plus BX1 plus U1. This is for the first observation. Second observation will be Y2 is equal to A2 plus BX2 plus, what's the next one? Y3 is equal to A3 plus BX3, sorry, B3X3 plus U3. It will go till how much? Go till 20. Y20 is equal to A20 plus B20X20 plus 20. Now I'll come to the problem of autocorrelation. What is autocorrelation? Sometimes this is independent. This is independent. It is assumed to be independent. That is what? It is an independent variable. Accordingly, you also, sir, U1 belongs to Y1. U2 belongs to Y2. What is the problem sometimes? U2 is explained by sometimes in time series. In time series. What is time series that I know, right? It's dynamic. The present is influenced based on the carry forward. Let's say, simple example. Today's return, stock price, best example. You know stock prices? Stock price, you know, right? The present stock price is influenced by yesterday's information, correct? Yes or no? The present stock price is not only influenced the present news, past shock. We call it as usually shock actually. News is not it creates shock in the. Understand? No, the present is influenced by. So similarly, Y1 is influenced by X1 and also U1. This is U1 is a part of, actually is a part of Y1. But what will happen? Sometimes the problem starts here. Y2 is not only influenced by X2 and U2 is a part of Y2, but these U2 is influenced by U1. Best example I told you. The present stock price is influenced by not only the present shock, previous shock as well, because Indian stock market is a persistent. You understand what is persistent? The shocks takes long time to die out in the stock market. Understand? No? You know the company profit is declined. The company announces the profit is declined today. The today's effect will be carried out for the tomorrow. That is called as the persist. Not only tomorrow. This will be carried out for 4 or 5 days. That is persistency, which we call it as Indian market is inefficiency. Some of you maybe in finance, they know it. The weak form efficiency hypothesis. Okay, anyway, so what is the assumption? They're all independent. So Y2 is influenced by X2 is fine. But what is the problem? Y2 is influenced by U1, which we call it as autocorrelation issue. That means we cannot estimate Y2. Why? Because Y2 is also a part of U1. Correct? No, because U2 is a function of X2 and U2. Correct? Sorry, Y2 is a function of X2 and U2. But since U2 is also influenced by U1, and whole equation is having no the interdependent effect will be carried forward. So that should not be there. That is the assumption. That means how to write? How to write? Expected value of U1 and U2 should be equal to 0. That is no autocorrelation. What is no autocorrelation? The expected value of U2 and U1 or U2 whatever it is, U1 and U2 should be equal to 0. So that means no autocorrelation. Suppose it is not equal to 0. What do you mean by that? There is an autocorrelation. So how to test it? There are different tests. Durbin-Watson test. It's common test. Durbin-Watson. Serial LM test. Lagrange multiplier test. Serial LM. There are many tests to find out the autocorrelation. Okay. So that is one thing. Hope you got idea about the autocorrelation. That should not be autocorrelation issue. Sir, how to prove it? I estimated a model. How to prove it? Through a test called Durbin-Watson. DW. Durbin-Watson. Durbin-Watson test. DW test. Durbin-Watson test. It should be equal to 2. When to prove that the Durbin-Watson test? No, I mean, how to prove there is no autocorrelation? Durbin-Watson statistic should be equal to 2. Please make a note. It should not be less than equal to 2 or at least close to 2. Very difficult to get exactly 2. At least close. Okay. So this is about autocorrelation. Sir, suppose I am not getting equal to 2, not even close to 2. I got 1.5, 1.5 or 1.6. So what is the solution? What is the solution? We'll discuss what is the solution. What you can do is, if you have autocorrelation problem, I'll suggest 2 solutions, 2 remedial measures. One is transformation of variable. Transformation of variable. Transformation of variable. Transformation of variable. One is transformation. Second one is first difference technique. First difference technique. We call it as delta. We call it as a delta. First difference technique. What is the transformation of variable? You transform the variable into log. You transform the variable into log. I gave an example. Now you take FDI. So you are normalizing the data. How you are normalizing data? You take another GDP. You are not, basically we are normalizing the data. How to normalize the data? By taking log FDI and log GDP. So there is any other example of transformation variable. FDI can be used as a FDI stock. FDI, this is FDI inflows. You can also use FDI stock. In some textbook I have seen when they are using FDI as a percentage of GDP. So FDI slash GDP. For example, you take another example, export. Sir, I have taken export. How to convert this variable? Export as a percentage of GDP you take. Nothing wrong. We call it as a openness. Export as a percentage of GDP you take, which we call it as a openness. Sir, can I take another? Yes. Export as a trade. Export plus import as a percentage of GDP. Divide by GDP or as a percentage of GDP. Okay. Divide by GDP or as a percentage of GDP. So what I'm saying, transform your variable and check it. The auto correlation problem will be removed. That means DW value will be close to 2. So this is an experimentation. So trial and error I'm saying this. There's no guarantee. Sir, how we get a clue about the transformation of variable? Please listen. You are a researcher. You are going to handle your, on the variable. You are going to do, research after collecting certain. You're going to build a model, construct a model after collecting the data. You are well versed with the data. So you know what are the variables can be interchangeably used. That is one thing. Second thing, the second one. Yeah, first difference technique. What is the first difference technique? You are differencing the data. What is differencing? Differencing, very important, plays a very significant role in the econometric techniques. So what is the differencing? Differencing means nothing wrong. A variable, the variable will be differenced once. The variable, the differenced once. What is the differencing? You take FDI and GDP, in terms of, like in terms of $1 billion, right? $1 billion. $1 billion. Let's say this is 110, for example. Here it is 120 and 140. Now look at GDP. Okay. So GDP, let's say, in terms of $1 billion, okay, let's say this is 250 less, very less. Okay, anyway, 2,500. So 2,600, 2,700, just an hypothetical. Now, what is the first difference of FDI? What is the first difference of FDI? YT minus 1. This is nothing but delta. YT minus is the delta. Okay, YT minus 1 is a delta. Okay. You are differencing. See what I'm saying? You're differencing the data and run it. Nothing wrong. Just there is a change in the interpretation. That's it. A small change in the, when you are using log, when you are using the actual data, and when you are using the first difference, yes, there is a change in the interpretation. That is what there is a log model, semi-log model, log-in model, log lean model. Yes, you're right, madam. Lean log model. All very simple. All can be estimated using OLS. But the thing is, interpretation changes. Nothing else. So, my dear students, please go ahead with the transformation of variable or go with the first difference because you know it. You try with the first difference. Nothing wrong. Only the slight change the interpretation for the writing, interpreting the regression model. Okay. Otherwise, transform the variable, a particular variable, in a meaningful, logical way that you only knows it. So let's say I want to examine the nexus between the foreign direct FDI and trade. FDI and trade. So what I will do is this FDI, I can use FDI as a percentage of GDP into 100 because I am expert in this. So international investment. So I can convert this variable into FDI inflows, which I collected from the World Bank database. Otherwise, I'll go with the UNCTAD, UNCTAD, the United Nations Conference on the Trade and Development. So I will use those data. They are providing every stock. Nothing wrong. Otherwise, what I will do is I'll go with the FDI divided by the GDP ratio, no problem, or multiply by 100. Transform it. Because I am in that area, I know that. Okay. So, same way, transform the variable and do it. To avoid what? Autocorrelation problem. There are only two solutions. Sir, still, I'll tell you. Sir, still autocorrelation persists. What to do? Change the model. Change the model. There is no other go. Okay. Change the model. Okay. So next, multicollinearity. 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 When you are estimating simple linear regression model, what is simple linear regression model? Anyone? What is simple linear regression? What is specification? The right side variable will be how many variable? Only one variable, right side. That is simple linear regression model. If it is more than one variable, it becomes multiple regression model. So this multicollinearity issue is attached with the multiple regression model where there are more than one variable in the right hand side. Okay. Sir, this is ready, sir. Okay, what I will do is, let me estimate the regression model, simple regression model. Then I will come to the multiple regression model. Then that time I will explain the issue of the multicollinearity. Okay. So please open your software. Follow the step what I am doing. Any database you take. Any database. So here I can work now, sir. நீங்க உட்காருங்க சார் உட்காருங்க கொஞ்சம் கைட் பண்ணுங்க சார் உட்காருங்க please you share. நல்லா ஓகே இல்ல சார் ஓகே ஓகே அதான் கேட்டேன். Okay. Now there are two data here. Okay, two data here. One is the spot price. One is the spot price here. The other one is futures price. Okay. One is spot price. The other one is futures price here. Two variables are there. If you want to keep, no one is as X, Y also fine. So what I'm going to do, I'm going to do the estimation. So what is the underlying theory behind this? What is the underlying theory behind this? The futures price, the spot is a function of futures. The spot is a function of futures. So whenever there is a change, this is related to the derivatives market actually. The simple, see, whenever the changes in the futures contract price, future price is based on the underlying price. What is the underlying? Spot market price is the underlying. Or you can see as a X and Y, no issues. So here I am going to specify as, which is a dependent here? The spot is dependent and futures is independent. That means whenever there is a change in futures and there is a change in the spot. So which is leading? Which is leading? Futures is leading and which is following? Spot is following. So accordingly, the hedging process is taking place. The arbitraging or hedging. So this is related to the concept of, with respect to the investor's perspective. the hedging. And the hedges are step into two markets and taking the buy and the short and the long position. So here, how the hedges are taking the position based on reaction in the future price. When the future price react first, and it will disseminate to spot price. This is the logic here. There is a theory. Okay. So what comes first? First, whatever the information disseminate in the market, which price reacting first? Futures. Which is following? Spot. I want to test it. There is other way around. I know that your query. There is also other way around. There also other way. That we'll see under the simultaneous equation model. Now, what I'm going to see, I'm going to estimate. I'm going to estimate the regression model. I'll show you the output here, estimate and show you. Okay. First, usually, okay, we'll go such that what we'll do. I'll save this. There it is. Okay. I'm just showing the outcome.
Uh-huh. Practical
The screen is shared, no, sir? Yeah, I'm opening the data. Yeah. Entire screen. Just do it. Can it click this? No. Actually, how to let me close this or minimize this. Okay. Sir, how to open the database through EViews? It is easy. Let me close it. I'm doing it again. Just see here. I'm just simple.
Hello.
Just dropping this is a data file on the software. Automatically, it will open. No need to go and open, copy, paste. That is old method, conventional method. Just say finish, over. The data is there. No. Now, you can see the data here. You can see the data as per the date, futures. And this is spot. Okay. So now what I'm going to do, this spot price in terms of rupees, future price in terms of rupees. I'm going to do the estimation. Okay. So go to quick. Estimate equation. So what is the dependent variable? Spot is the dependent variable. Space C, futures. Okay. Okay. Over. Nothing. So very simple. The spot is the dependent variable. C is the constant. And futures is the independent variable. Click OK. So we got the result now. Okay. We got the result. Now this is actual data. What I use actual data. Okay. So you see here, futures spot depends on futures price. Okay. So what is the coefficient? 0.99. 0.99. Okay. So you can see the T statistics associated with the coefficient. Okay. You can see the T statistics value, as I told no in the morning. So T test statistics associated with each coefficient, and you can see the probability value also along with the T test here. So now, what come to this coefficient is very important. So what is the sign I'm expecting? I expected positive. Yes. Even negative also, you just do a research why it is negative, but here it is positive. So futures price has a positive impact on spot. Correct? No, futures price has a positive impact on spot. So how to, so here, that is one thing. Look at the size. What is the size here? 0.99. So how to write the interpretation? That means there is a 1 rupee, if you want to go with the rupee, because this is in terms of rupees or in terms of the lakhs or whatever it is, or thousands. So here, actual data I used. So let's say 1 rupee increase in futures price. 1 rupee increase in futures price leads to how much paise increase in spot? 0.99 paise was increase in spot price. Okay, so this is what the interpretation in the actual data, with actual data. With the actual data. Look at the probability value. Probability value is less than 0.000. It is significant. That says that future price has significant impact on spot price. Okay, and so even the interpretation varies in accordance with the theory also. You please go ahead. The another thing, I explained about the autocorrelation, right? Autocorrelation. So what is the autocorrelation? How to see the autocorrelation here? Durbin-Watson statistics. So here you can look at the last one. Look at the last one. So what is the Durbin-Watson statistic? It should be equal to 2. So it is 1.13. And this model, whether it is a positive sign, sorry, and look at the R square value. What is the R square value? R square value is 0.99, which is very close to 1. So you'll be very happy that yes, sir, R square value is very close to 1. Because the R square value lies between 0 and 1. If it is close to 1, so model is, this data is best fit for this model. Understand? No, this data what you use is the best fit for the, or this model is best fit for the data that you used. The model fitness, the model is best fit for the data that you used, the right way. Okay, so 99. Okay, you are very happy. Yes, it is very 99. Yeah. But what is the problem here? And this model is suffer from Darwin-Watson. No, the autocorrelation issue. 1.13. Okay. One more thing I want to tell you. Normally, in econometrics, we are talking about normalizing the data. Normalizing the data. Why normalizing the data? The units of measurement is different. The unit of measurement is different. GDP in terms of $1 billion. But you are using inflation. How to measure inflation? Yeah, you are using CPI. Are you using WPI? Other variable also you are using a secondary school enrollment ratio for schooling. See the combination of different variables. Understand? No? You are using the same regression model. You are using index. You are using the actual data. You understand? No? You are using the ratio as well. So some studies use percentage also. Okay. So what to do? So we should go for the normalizing the data. We try to minimize the variation in the data. We try to minimize the variation in the data. Variation in data. So how to do that? We'll go for taking log, natural log. Nothing wrong. Please go for taking natural logarithm. So whenever you go for the econometric applications, so please go for taking natural logarithm. So how to go for natural logarithm? How to convert? Natural into natural logarithm? You do it in the Excel itself, or you can do with the EViews also. You can do it. You can convert. You can convert. So what I'm saying, it is better to go with the Excel and convert it. Otherwise, you have to generate series using EViews. Okay. So in Excel, because each variable you have to do in EViews, because we are using a multiple variable. So what you supposed to do? I'll show you how to do that. I'm going to convert now. Convert this S and F. S and F. So how to do now? This is logarithm of spot price. So equal to ln. I know you people have various questions, but one by one, the session, each and every session, it will be clarified. Because some of you may have a doubt, sir, is estimating the model with the actual data. Actual data. Actually, why? Actually, no, it is better to minimize the variation among the data, with the data. Okay, variation on the data you are using. So I just converted into logarithm. Okay. Same, just drag it. Just drag it. Okay, just double click here. It will be automatically converted. Understand? That's it. So now what I can do is, so S is log of spot. I told you, interpretation changes. The previous output with respect to rupees, and this with respect to, once you convert it into log, I'm going to use the term unit. Okay. So 1 unit change in future is going to we are going to see how much change is going to take place in spot. Unit, because we converted into the natural log. Okay. So which is equal to, we convert it into log. So what I'm going to do, that just save it, close it. And I want to add again. So instead easily what I will do is, you can just drag it and get it the other one, no problem. See here. So I got this S, F. Now what I will do is, I'll go with the OLS. Go to quick, estimate equation. First comes spot, C, F. Click OK. Yeah. Okay. Now see the result. There is no change in the result. There is no change in the result. There is no change in the result, because you can see here the Durbin-Watson, slight improvement is there. Slightly is from 1.13 to 1.27. So that this technique, I convert into log. And what I am saying, you can go with the transformation of variable, the equation with a variable, transform it. So whatever the variable that you incorporate the equation or the model. Okay. Otherwise, you go with the first difference technique, convert into first difference and see. Convert into first difference and see. Now, how to convert the first difference? Okay. So here also, now right, this is constant intercept and this is the futures price. I convert in log. Like, just to normalize the database, nothing wrong in it. And there is you can see, there is no change in the output, right? So you may have a question, sir, can I go with the actual data? Yes, you can go with actual data. It is better, if you normalize it, better. Because everything, in the same unit of measurement, I convert into log. Okay, so that, so we can do both. It's optional, actually. So I will go with always, convert into log to, minimizing the variation on the data. Otherwise, the standard error become huge. The standard error become huge, actually. Okay. Variation. Standard error means what? Standard deviation of a statistic. Okay. So what we can do is, I'll close this. what I will do is, I will go with converting the first difference. You can also do with the EViews. How to do EViews with the first difference, I'll show you. Same thing only I'm doing. How to convert the first difference? Same thing only. Okay, go to quick. Estimate equation. D bracket. Yes. What is D stands for? Differencing. Space C space D F. Sorry. Okay, now you just click and see. See, audience, see the change in the result. See the change in the result, the first difference. When you go with the first difference, I just converted into first difference. And there is a change in the result, but you can see the DW statistics has become 2.50. So what this indicates, what it implies, transformation of variable, or go with the first difference technique. One thing I told you. Sir, the differencing and log, listen, the differencing and log should be decided by the unit root test. Unit root test. I don't know how many of you heard about unit root test? Stationarity test. Log and first difference should be based on the differencing, based on the unit root test. We call it as a stationarity test. We'll see later in the afternoon session. We'll see. Yes, sir. One, no, that is what I tried. No, first one is actual data. First one, I estimate the actual data. And second one, I just convert log and C, just normalizing my own way. Same result only. I convert it into first difference. And there is a change. No, sir. That is the log data only. Differencing of the log only. What is S? S stands for log of spot. Okay, directly. Go ahead, no problem. Yeah, differencing. Yeah, correct only. It's no issue, sir. Now, I will make this as a spot. I will make this as a futures. Now we'll see. Yeah, no, but because this is what actual data, log data. Anyone you can do. But first differencing, my valid point is the first difference and log should be based on the stationarity test. Stationarity test. Suppose we'll see later. Unit root test, we call stationarity test. Suppose your data is not stationarity at a level, let's say it is actual. Actual level means the actual data. It's not stationary. So we have to go for the first difference. We have to go for because we need to use the stationarity data. Otherwise, no, it is a biased one. The result what we got is a biased. So I'm not giving information on it. So simply no, we should not convert into first difference directly. So that should be based on ADF. I mean ADF means augmented Dickey-Fuller test or Phillips-Perron test. So that's what generally I said. We'll try with transformation of variable means not a whole equation. Maybe one or two variables you can change it with a meaningful way, logical way. That you can possible. That is possible. But what I am saying, but any circumstances, we should not deal with, estimate with the non-stationarity data. Non-stationarity data. The data is stationary, go for the regression model. Otherwise, no, the result becomes spurious. So this is what I want to say. But the thing is, this is the database which I have taken. This is a daily database. I know what is the problem here. What is the problem is this data is as a severe autocorrelation problem. See here how to, I'll tell you. DW statistics is sufficient. I'll show you. Go to view, go to actual, with the actual fitment estimated residual table. See here. Actual means the actual data. Actual data. What I have in actual observation. What is fitted means estimated. Estimated by which model? The OLS model. Yes, that's what I told you. Okay, it is actually in minus because differencing data. This is into plus. That's anyway, depends upon the model you are estimating. Then what is the difference? Difference is minus 20.4522. Look at here. So there is a plot of this residual also. So look at here and see, you can see, I told you, no, this is the residual series. But there are certain assumptions with respect to this, the residuals. Okay. So I can't infer anything with this residual. Okay, I can plot and see. But you have to use the statistical test to prove it. So just hold on. I'll show you the graph. Yeah, see. It is unstable. Correct? No, it is not stable. Okay, it is not stable. It is time varying. The mean and variance are time varying in nature. Time varying means what? Constantly it's changing. The average, the average of the residual is constantly changing. The mean is changing. See, ups and downs. It's not with the limit. You can see, madam, this is the line, no? The line is the width of the the stability. You can see the ups and downs here. Okay, there is no more fluctuations. So obviously, from this is an old method based on ACF and PACF. That is different. I'll come later. So here, yes, this is, we can also, through the plot, we can say that is a different plot, ACF and PACF. But here the residual, no, it's not stable. Okay, so it should be the time invariant, how to say, time invariant, because this is the daily data which I have taken. Anyway, so go to the model, all right? So R square also is very less. So what I'm saying, when you are going with the OLS, so when you are going for OLS model, with respect to this econometric modeling, first to go with the stationarity test. Stationarity test for all the variables. Then you can conduct OLS model. This is my first thing. Second, transformation of variable is applicable. It's applicable. One or two variable you just convert and see. But with the convert and the see in the sense, with a meaningful way, the logical way. That's what I want to tell. So these are all in your hand because you are a researcher and you are dealing with the different multiple variable, the different several variable. So which variable to be included, which variable to be transformed. Even if you transform, what is the meaning it will convey, everything matters. It's not easy. Still, sir, I transform the variable. Sir, I have just first difference technique. First difference means all the variable you can go for first difference. I will tell you why. Most of the variables are stationarity at the first difference. What I told you? Estimate the model with the stationarity data. So most of 99% of the data variables will be stationary at the first difference. So you can convert and model and run it. But still, sir, autocorrelation here, see, still autocorrelation, what to do? I converted with raw data, with first difference data, sir suggested. No, what happened? Still end up with the autocorrelation. So what I have to do? I have to change the model. I have to change the model. This is another viable situation. Okay, so afternoon we'll discuss about the stationarity and ARIMA model for the forecasting. Okay. Sir. Sir, at what time shall you? So 2:15 we'll meet audience, 2:15. Okay, 2:15 will come. We'll start with the stationarity test on the ARIMA process. Okay. You'll get more clarity, nothing to it. More clarity you'll get.